Another optimization algorithm which is used in neural network training is AdaGrad. AdaGrad is abbreviated from adaptive gradient. So in adaptive gradient, if we compare it with momentum, so in momentum we are using sum of gradient values, sum of previous gradient values, while in AdaGrad sum of gradient scared values are used. Number one, so these sum of gradient scared values are used for what? For controlling the value of this alpha, this learning rate. So by dividing this learning rate with this GT square root, what happens that we have an adaptive algorithm. So we are adapting or changing the value of alpha for different weights. So one of the key features of adaptive of AdaGrad is that it has different learning rates for different features, like for different weights. So for one weight, the alpha value will be different depending upon the value of GT, and for other weight it will have another value of alpha depending upon the value of GT. So it also helps because it has different learning rates for different weights, so it also helps to for AdaGrad algorithm to move in different directions. So when we will see its simulation, then we will come to know that what do we mean by progress of AdaGrad in different direction of weights. Another benefit of AdaGrad is this point, that the frequent weights, their learning gets slower, and the infrequent weights, their learning speeds up. Why it happens? Because those weights which are being updated for more times, so it will have a higher value of gradient, and because of that, those weights will have a lesser value of learning rate, and this will slow down the learning of frequent weights. While in case of infrequent weights, like those weights which are getting lesser opportunity for their updation, they are not being updated too much frequently. So what happens? Their GT value, that is low, and because that is low, it has higher learning rate, and because of that higher learning rate, those infrequent weights, they get more opportunity to update their values. So in this way, AdaGrad has the ability to move the algorithm in different directions. So, however, in spite of all its benefits, the AdaGrad also has a weakness, and that weakness is that as the GT value keep on growing with the passage of time, so this alpha value, it gets lower and lower, and because the learning rate becomes very small, so the overall learning of AdaGrad, it also becomes very slow. So we will see in this simulation that because of this slow update or slow progress of AdaGrad, we have to make some changes, and its better version were introduced, which is called RMSProp. We will also see that algorithm. So now if we look at this simulation, so we can see two algorithms. One is the gradient descent and the other one is AdaGrad. So we are comparing AdaGrad with the gradient descent. So what we can see that this gradient descent, the blue one or light blue one, this is a gradient descent, and the white one is AdaGrad. And this gradient descent, the blue one, it is in the beginning taking path towards one axis or towards one weight, and then after reaching at particular point, it is turning towards other axis, along other axis. So however, we can see that in case of AdaGrad, so it is starting initially from this point, and then it is progressing with respect to both weights, because it has two axes, x-axis and y-axis, and the z-axis is the magnitude of the surface. So here we have, you can consider that we have only two weights. One is along x-axis, another one is along y-axis. This is x-axis, this is y-axis. So this AdaGrad, it is progressing, it is taking progress or taking steps in both direction at once. So because of that, it is reaching to the minimum point in less time as compared to the gradient descent. So another optimization algorithm is RMSProp. As we said that in AdaGrad there is a problem that gradient squared, which is in the denominator, if we see here, which is in the denominator, that denominator value that keep on increasing with the passage of time or with the number of iterations. So it has a very adverse effect on this learning rate value, that is the learning rate becomes very small. So because of that, the whole progress in the algorithm becomes slow. So RMSProp, it tackles with this problem in the sense that instead of using all the previous magnitude, all the previous gradient squared values, like here it is using g of t is using all the previous sum of gradient squared values, and all the previous gradient squared values are used. So in RMSProp, what happens that it uses a forgetting factor, a particular variable rho that is used, and what happens is that with the help of this rho, it gives less weightage to the sum of previous gradients, and it gives more weightage to current gradient square. Like if we use the rho value of, let's say, 0.1, so what will happen that the previous sum of magnitude square terms, this gt, it will be multiplied by 0.1, so it is given the weightage of 0.1, you can say 10%, and this one, the current gradient square, that will be given the weightage of 1 minus 0.1, which is 0.9, like 90%. So because of that, because of that, this gt, the gt value that is calculated in RMSProp, it doesn't becomes as bigger as we have seen in AdaGrad. So because of that, this problem of small or diminished learning rate in AdaGrad is solved in RMSProp in this way. So if we look at the simulation or visualized RMSProp with the AdaGrad, then the picture will be more clear. Yes, if you see here, we have two algorithms in comparison. The one is the green one. Green one is showing RMSProp, and the white one, which is showing AdaGrad. Yeah. So in AdaGrad, you can see they both started from the same point, initial point, but RMSProp, that is moving forward towards the optimum point, and AdaGrad is lagging behind. And this happens. So what does it show? That the AdaGrad, it has slowed down, and that has slowed down because of because its learning rate is becoming very small with the number of iterations, while RMSProp, it doesn't have that problem because it has already solved the problem of diminished or diminishing learning rate. And you can see here, you can also see that this one, the green one, the gray wall behind the green point, and the gray wall behind the white ball. So these are actually showing the magnitude of sum of gradient squared. So you can see here for green ball, the GT, capital GT term, it is of an adequate value, but for AdaGrad, the GT value is getting larger and becomes very large. So because of that, AdaGrad slows down. However, RMSProp that keeps on progressing. And finally, we have Adam algorithm, adaptive movement estimation algorithm, which actually combines the benefits of momentum as well as RMSProp. So because of the momentum, it also gets momentum or speed, which helps it to come out of any local minima. And because of RMSProp, it have also got adaptive learning rate. Adaptive learning rate and the progression of and gradient in different directions. So here this term belongs to momentum and this term belongs to RMSProp. So normally Adam is used widely whenever we implement our neural network algorithm or neural network architecture in our TensorFlow or PyTorch. So this is the update equation for Adam. Here this VT term is being used, and this VT term that is actually being calculated, that is RMSProp part, and here this MT, which is momentum part. So in this way, Adam is actually combining the best of both worlds, you can say, momentum and RMSProp. So now we also see the simulation or visualization of all those algorithms. So here you can see, this is the simulation of all algorithms. So it is using 5 algorithms that we have discussed: gradient descent, or you can say simple gradient descent, and momentum, AdaGrad, RMSProp, and Adam. So this blue ball, that is Adam, and the surface is like it has two minima. One is lower local minima and the other one is global minimum point, and it is starting. So just see here that 5 algorithms, they are starting. All of those algorithms beside Adam, they all converges at this local minimum point, but Adam, it goes to the global minimum point. So that is the beauty or the power of Adam, which makes it a go-to algorithm for nearly all neural networks implementations or trainings. So that is all about the optimization algorithms which are used for neural network training. And those algorithms are also used for other variation of neural networks, which we will study later in this course, like CNN, convolutional neural network, and RNN.